It is Jeff the Maintenance Man. How y'all doing? In one of my videos, if you haven't seen it yet, it's the 60-ton unit um, air conditioning tour. And in that video, I said, well, I do know what this does. And I pointed to this thing here, that you see on my screen, which is the V1000. The V1000 basically is a pulse width modulator controller, or its actual name is called a variable frequency drive. It's called a VFD for short. And as you can see here, we have a nice grainy photo. I didn't have a better potato, I guess, to get this picture, but anyway, here's some information on the thing. It can go up to like 6,000 hertz, I guess. And we're going to go over what this does. We're not going to go over how it works, but we'll go over what it does so you can get an idea of why this is in this unit and why wouldn't you just hook it up to a relay that starts. So I got this software that's called Protus 8, which is awesome. I love it. I've used it for years. I just got the newest version of it, upgraded to it, and we have a schematic here. And now this is not the schematic that is for that controller. It's far from it, but this is the basic schematic that I can give you that explains how that thing works. I mean, there's a lot more going on in the VFD than there is in the schematic, but this is just for the basic concept of how that thing works. Okay, so let's just go over real quick the schematic, so you kind of know, you can kind of follow me, and then you'll know what I'm talking about. Up here, this is nothing but our clock for the chip. So this sets how fast the chip is running, and in this case, it's 1 megahertz. You got like 2 buffer capacitors and a pull down resistor. Could be a pull up, I don't know. A 1 meg transistor, current limiting transistor, probably. So anyway, we don't even have to worry about that. That just controls the clock processes in the chip. This over here is just a switch, and it just goes through kind of a variable resistor, and it goes to 5 volts, but in our case, this would probably be hooked to a couple 100 volts, maybe 200 volts or something along that lines of that. So we're just going to call this the thermostat area here. Okay, your variable resistor is going to be your temperature up and down, which will then switch on this switch, telling the microcontroller, hey, you just switched on the switch, and turn on the motor. Now, I know what you're saying. Why don't you just have a switch that turns on the motor? Well, in that unit, this motor here is 10 horsepower. If you hook this switch to even a relay, and then from the relay to the motor, it'll probably melt or burn out the relay. It would have so much inrush current, is what it's called, that it would flip the breaker off, melt wires, burn up wires, whatever. The reason this happens is because this is a disc of magnets, basically. And, well, when they're electrified, they're magnets. So you have 10 horsepower, you plug that in, right? Well, this thing's at a standstill, so it's got to get going. So what this whole circuit does here, and what that VFD does, this thing, is it pulses the electricity to the motor. Let's see what that looks like in the schematic. So it's off right now. The motor's not spinning. keep an eye on these two test points. This I'll explain real quick before I turn this on. Right here, oscillator number one and oscilloscope number one and oscilloscope number two. So oscilloscope number one, the program within this chip is going to start at a high. So it's going to turn on, and then the microchip will take over and say, I don't want you on. I want you on for this period of time, this period of time, this period of time, and get longer pulses till the motor gets up to speed. And then it's going to turn off the electricity, so you're not using any electricity, and keep pulsing it, pulse, like this. And it's going to go forward, reverse in this case. But in our case, this would just continue to pulse until it's on, and then the oscillator 1 would actually turn the power off in increments while this is pulsing just a frequency. So then you don't get that inrush current that we were talking about. You get this nice just pop, okay, turn on, and then this is in milliseconds. I mean, but it's enough. That's all you need. So this, let's say this is circling, and as soon as it gets here, it pop, 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 pop. So it gets faster and faster and faster, and then it gets the motor up to speed. And then after the motor's up to speed, all you need to do is pop it every maybe second or so, because the momentum of the motor spinning will keep it turning. So there's no point in having electricity to a motor constantly if you can just put electricity just every once in a while. So you use less electricity. That's what the whole idea is behind this, is to have variable speed and make it where it's controllable in an environment that you can use less electricity and bigger and more efficient motor. Because if you didn't have this controller, then this motor would use so much electricity to be on 24/7 and this, that, and another. So let's see how this works real quick. Let's say the temperature in the room got to 72 degrees and it's supposed to be 70. Well, the thermostat, which is just a switch basically, would switch on, and the motor would get pulsed. Over here it's pulsing it. Right here you can see it, and then it goes into reverse. In this case, in this program, it's going forward, reverse. So they turn on this to bring it backwards, and this one pulses it back forward, just to give you an idea of how that works. Now the display, let's just not even worry about that. That's kind of measuring the RPMs or something, but who cares? So when it's up to temperature, it just simply goes off, and the motor winds down under its own momentum, further giving you just that tiny little boost of cooling or heating, whatever the unit may be in. So this basically is a really more efficient way of running a motor. You could probably put an oscilloscope on this. Now I can't do it right now, but you could probably put an oscilloscope on this and see the current or a multimeter, and see the current that's going in there. And in this case, you would see just tiny bits of current, but the motor requires, let's say the motor requires 20 amps to turn on. All you gotta do is pulse that 20 amp just for a fraction of a second, and it'll spin the motor. Do it for another fraction of a second, it'll spin the motor again, and spin it, and then get your pulses going. It's like pressing the power button on something and just getting faster and faster with it, and you'll see the motor will start spinning faster. So basically that's all it's doing. This microcontroller is your finger pushing a button that is putting pulses through here. These little doodads here are Darling transistors, and what they're doing is taking a load off of the microcontroller here, which is a MC68HC118A8 Alpha 8. So anyway, so one's responsible for the reverse and one's responsible for the forward. So, and essentially with the VF1000, which is here, it can pulse out 60,000 hertz, which is 60 times a second, or 6,000 times a second, I'm sorry. So yeah, so it can get this motor going pretty fast. For an example, if you took this circuit and you put maybe a AA battery, let's say we downgrade this motor to a 12 volt motor, which in this case, in this schematic it is. Let's say you take a battery and you put it in here, like a AA battery, then this will send pulses out of here. The Darling transistors will amplify and take the load off of the microcontroller at the same time. But you could essentially run this, even though it takes 12 volts of power, you could pulse it. It would take a long time, probably a long time to start up, but you could get some crazy speeds out of this thing just pulsing it with like 1 volt or something. And then that 1 volt will just turn into 6,000 times 1 volt, which we're not amplifying the voltage, we're just amplifying the frequency. So you have 1 volt, but you have 1 volt going to that motor 600,000 times a second or whatever, then you can get pretty crazy with it. And you can actually tune it in. If you had something like this variable resistor here, you could tune it in to where it's pulsing this thing every time, like the north or the south pole of the magnet, and this is called resonance. And resonance frequency is when every time that north pole goes here and that south pole is there, you pulse it, and you can just keep going whap, 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 whap. So you could, yeah. So I'm not saying that's even reliable. Like if you would use a 1.5 volt battery on a 12 volt motor, you probably want to go ahead and pulse. It'd be more efficient to pulse it with the 12 volts every time, and then it'll get up to speed faster. So you would, in the end, you would use probably more energy. You'll use less volts, but it still would be not as efficient as using the actual voltage rating of the motor. So again, all it does is over here, it's pulse, 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 gets it up to speed. This one comes on over here, and this pulses it back the other way. Pretty cool little device, actually. I had to do a little bit of research to figure out what that thing was when I first saw it. I was like, what is this thing? Variable frequency drive, but it's basically a pulse width modulation motor controller. This one is using like a Darlington bridge driver kind of thing here. That's what I was going over earlier, but that's a whole different video itself on how that works. So yeah, this is a motor driver that can drive a motor in any direction. And basically, this is a motor driver that can drive it in any direction. You can reverse, speed it up, slow it down. It actually has sensors in it itself that can take compensation for, like, let's say if we didn't change the filters, it would try to speed up the motor to compensate for it. Stuff like that. So that's basically how that little V1000 thing that I pointed to in the video works. It's not too terribly complicated. YouTubers, if y'all have any questions for me or any ideas about how I can make your life more pleasurable, you let me know. Alright? Y'all have a great day.